Limiting reagent, you need to remember, I talked about three very important points. Limiting reagent is the one which is consumed completely. With the condition that if both get consumed completely, then there is no limiting reagent. We don't say that there are two limiting reagents. No. If both are consumed completely, no limiting reagent. Second, because it is consumed completely, it will stop the reaction. This will be driving the reaction. So limiting reagent will decide the amount of product because it will be consumed completely. The other one will be remaining there. So the remaining amount is not reacted. Because the remaining amount is not reacted, that will not correspond to product produced. It decides the amount of product. These 3 points to be very clear. That is actually the definition. These 3 points. It is consumed completely, it stops the reaction and decides the amount of product. Now the question. 3 grams of hydrogen react with 29 grams of O2 to yield H2O. What is the limiting reagent? And condition I told you.
Sir, hydrogen.
Yes. 2H2 plus O2 gives you 2H2. This is the balanced reaction. Once you will write the balanced reaction. Then according to balanced reaction, you will write R. R means 2 moles of hydrogen react with 1 mole of oxygen and produce 2 moles of water. But because here we are talking about in grams, convert these moles to gram. And you know how to convert. Multiply moles
Given
by,
mass 1 molar.
uh, if you want to, yes, the formula will be that one. But in grams, it will be moles multiplied by molar mass. 2 moles multiplied by molar mass of hydrogen. 1 mole multiplied by molar mass of oxygen. Okay, 2 moles multiplied by molar mass of water. Okay. And you can see that 4 plus 32 will be 36. That is the law of conservation of mass will hold true. So this is as per the reaction. And as per question, you have 3 grams. I'm writing it 4 grams, 32 grams, 36 grams. As per question, you have 3 gram and 29 gram. Now to get the limiting reagent, you will calculate Q by R ratio. Do you remember that? Q by R ratio? Everyone?
Yes.
Yes,
Good.
sir.
Yes, sir.
Yes,
3
sir.
by 4.
Yes, sir.
Good. Now 3 by 4 will be 0.75. Now here 3 by 4, if you have 32 as the denominator, 3 by 4 would have been 24 by 32. Okay. It means it is greater than 3 by 4. It is 29 by 32, not 24 by 32. 24 by 32 would have been 3 by 4. 8 3s are 8 4s are. So it means it is greater than 0.75. It means this one is less. Which one is less? Which one has less ratio Q by R? That is the limiting reagent. So hydrogen is the limiting reagent. Up to here, it should be clear to everyone why we are saying hydrogen is the limiting reagent. However, remember, you will not be writing this part. Your teacher will not understand what is this Q by R ratio. So you will write like this, that this is the given and reaction. So you will write as per reaction. And when I say as per reaction, as per balanced reaction. And this one you will write given. Then you will write a statement. You will say as the amount, given amount, three gram of hydrogen is not sufficient to react completely with oxygen. Hence, hydrogen is limiting reagent. That's how you will write. Okay. Otherwise, there is a way of unitary method. Okay. And some teachers will ask you to apply the unitary method to find out which one is the limiting reagent. How will you do that? In that case, you will write First, you will write the same thing, okay? As per balanced reaction, and then as per the question, you will say as 4 grams hydrogen, always as per reaction, as 4 gram hydrogen react with 32 gram oxygen, hence 3 gram hydrogen will react with 32 by 4 into 3. That is 24 gram. But you have 29 gram. It means that is O2 is in excess. Is that clear what I am saying?
Yes.
Everyone? It required 24 gram,
Yes,
but
sir.
I have 29 gram. So it means O2 is in excess, that is hydrogen is limiting reagent. Hydrogen is less. So that's how you will get. So you got hydrogen is the limiting reagent. Next, calculate the maximum amount of H2O that can be produced. It means hydrogen will decide the amount of H2. So what is as per the balanced reaction, the ratio is 4:36. So you will say as 4 grams of hydrogen produce 36 grams of water. We will not consider oxygen now. Oxygen will be out of picture. So we will say as 4 gram of hydrogen produce 36 grams of water. Hence 3 gram will produce 36 by 4 into 3,
27 gram.
27 grams. So that is the amount of water, 27 grams, and you can write at the same time in moles also. If amount is asked in chemistry, it is advised that you write both in grams and moles so that no marks are deducted. So in moles, it will be given mass divided by molar mass of water, that is 1.5. So you will write the water produced will be 1.5 moles, that is 27 grams. This will be the answer of second part. Anything is not clear, you should ask. Okay. Third part, calculate the amount of one of the reactants which remains unreacted. So obviously, oxygen remains unreacted, and how much? You know that I calculated 3
So
grams will
5
require. Yes,
5 gram.
3 grams required 24 grams only, but you have 29 grams. It means 29 minus 24, 5 grams of oxygen remained unreacted. All points should be clear. Okay. Next question. So,
Sir,
yes,
so we have to also change this into moles.
yes, you can. Okay, because here it is written 5, you can, but it is not, straightforward. You need to divide it by 32, 5 by 32. So may not be, but that is advised only. You will not get your marks deducted even if you don't write moles. Suppose here you write just 27 grams, your marks will not be deducted unless your teacher, is very strict, and he or she has specifically mentioned that in your class that you need to mention that in moles as well as in grams. Okay.
Okay, sir.
H2 27 grams and 5 grams 0.156 mole. So even if you don't mention the moles, marks will not be taken. Next is concentration of a solution. So different ways are there to represent the concentration. One is mass percent, and mass percent is actually of solute. Okay, normally, but sometimes of solvent will also be asked. Concept is very clear. It is actually mathematics that suppose this part you have solvent, say water, and this part you have solute. This whole is solution. So you can calculate percentage. Suppose if this solvent is just 4 grams and solute is 1 gram. So mass percent will be 1 gram divided by total 1 plus 4 into 100. That is how you calculate the percentage when some values are given. 1 by 5 into 100, that is 20%. And mass percent of solvent will be 4 divided by 1 plus 4 total into 100, that is 80%. I hope that this is very easy one because you have been doing these type of problems in maths from your 7th, 8th grades.
Yes.
Should not be any problem, right? So the question is, a solution is prepared by dissolving 2 grams of substance A in 18 gram of water. Calculate the mass percent of solute. Just don't tell me the answer. Write the answer in chat box. I want to just check that whether you got the idea or not. You need to calculate the mass percent of solute only. Samad, Atman, Yash, Kavish, Arjun, Tanishi. Correct. Tanu, you need to check the answer. So it's again the same thing. 2 gram solute, total is 2 plus 18. Solute plus solute into 100. That is 2 by 20 into 100. That is 200 by 20, 10%. If 10% is solute, 90% will be solvent. Next one, mole fraction. This is again the same thing what you have done type of questions that in a bag, suppose you have 2 red balls and 5 green balls. Okay, so the fraction of red balls,
25%.
2 by 2 plus 5 total, isn't it?
So 1 by 4.
2 by
No,
7.
sir, 2 by 7. 2 by 7.
Green balls fraction. Number of green balls divided by total balls. 5 by 7.
5 by 7.
And sum of all fractions should be 1. So 2 plus by 7 plus 5 by 7 will be 1.
Yes, sir.
So this is actually nothing but usage of fraction, what you have been doing from your primary classes in chemistry. Okay. So whatever moles you have of solute, you need to have that in the numerator. If mole fraction of solute is asked, so solute moles will be in the numerator. Total moles, that is moles of solute plus moles of solvent, will be in the denominator. If suppose the same question is for mole fraction of solvent, there are two ways to that. For that, either you change this to solvent, denominator will remain same, total moles, or mole fraction of solvent will be 1 minus mole fraction of solute. So in many cases, you will be asked or you will be required to calculate mole fractions of both, mole fraction of solute as well as of solvent. So in that case, you need to just calculate of solute, and after that to calculate for solvent, subtract it from 1, because sum of all mole fractions will always be 1. Percentages will sum up to 100. Fractions will sum up to 1. That's why. Next is the molarity. And molarity is how many moles are in 1 liter of the solution. So suppose, just to understand it very clearly, suppose this is 16 liter, total volume 16 liter solution, and it has total, say 4 moles, total 4 moles. But the definition of molarity is that I need in 1 liter, not in 16 liter. So either you apply unitary method, that as in 16 liters we have 4 moles, hence in 1 liter we will have 4 by 16. That is 1 by 4, 0.25 molarity, mole per liter. That will be molarity. So effectively
So
molarity.
capital M.
Yes, capital M, correct. Okay. So capital M, molarity, is nothing but how many moles are there in 1 liter of the solution. So another way pictorially how you can understand, if total moles are 4, you divide this whole in 16 equal parts, 8 parts, 16 equal parts. Now in this 1 liter, now this is 1 liter because I have divided 16 liter in 16 equal parts. Whatever moles are present here, those will be the molarity. So if you divide 4 into 16 parts, again the same thing, you will get 0.25. That will be the molarity. In 1 liter, you will have only 0.25 moles. Normally, you will be required to calculate the number of moles of solute and you will divide that volume of solution in liters. Remember, the volume has to be in liter. Next one is molality. Similar thing, number of moles, but in 1 kilogram of solvent. You don't consider here solution. Rather, you consider only the mass of solvent, that too in kilogram. So with practice, you won't make any mistake. But if you don't do practice, students I have seen made mistake that they consider the mass of whole solution. No, mass of only solvent. So if somehow you calculate the mass of solution, you will have to deduct, you will have to subtract the mass of solute. Okay. So in few questions, you will be given the volume of solution and you will be given density of the solution. That will give you mass of the solution because you know density is equal to mass over volume. From here, you will get mass equals to density into volume. But this mass, okay, will be of whole solution, not of solvent only. Because this volume is of solution, this density is of solution. So this multiplication will give you mass of solution. Hence, to get mass of solvent, you will do this M, which is mass of solution minus mass of solute. You will subtract the mass of solute, then you will get the mass of solvent. So you have the total mass, you will subtract the mass of solute, then the remaining one will be mass of solvent. That's what you need to remember. Now the question, calcium carbonate reacts with aqueous HCl to give calcium chloride and carbon dioxide according to the reaction. What mass of calcium carbonate is required to react completely with 25 ml of 0.75 mHCl? Whenever you see this type of arrangement, few ml of these many mHCl, capital M, right, molarity. Their multiplication will give you number of millimoles. Number of millimoles, why? Because it is in milliliter. If it would have been in liter, then it will give you moles. But because it is in milliliter, so the millimoles of HCl, which you need to react, okay, will be 25 into 0.75. This is a millimole. So moles of HCl will be when you divide this by 1000. These many moles of HCl you have. Now, if I write this reaction, CaCO3 plus 2HCl and CaCl2 plus CO2 plus H2. Question is, what mass of CaCO3 will be required to completely react with these many moles? That's the question simply. Okay. And if you multiply these, right, 25, 24.75 will be, okay, 18. Means it will be around 18.75. So it will be 18.75 millimoles or 10 power minus 3. When I multiply this one, I will get 18.75. Why I will get? Just to do calculations and learn this type of calculation that you can do calculation in your mind. Because I didn't multiply 25 with 27.75. I multiplied 24 and 0.75. 0.75 is 3 by 4. So I quickly calculated that it will be 18. And remaining one I multiplied by 3 by 4. That is, it will be 0.75. So it will be 18.75. So quickly you can do calculations in your mind. If you split, and this technique you have already learned in your previous classes, if you remember that instead, if you have to multiply 17 into 32, you don't multiply this, rather you do 30 plus 2, isn't it? There were techniques in your 7th grade, 8th grade. That's what
Yes,
you
sir,
need.
distribute.
Yes, distribute. So apply it like that, and you will be able to do calculation in your mind very quickly. That is required specifically in competitive examinations. You will not have, almost always, you will not have sufficient time. So you need more time. Now, the question becomes just a stoichiometric ratio question, because if I say X and I'm just writing it here so that I can write here according to the reaction. According to the reaction, 1 mole of CaCO3 reacts with 2 moles of HCl, right? This ratio is given. So you need to calculate these many moles will react with how many moles of calcium carbonate. That is asked. Is this part clear or not? Question asks that you have these many moles of HCl. After multiplying these two, I got the millimoles. Millimoles I converted to moles. It means I have moles of HCl. And question is, these many moles will react with how much calcium carbonate? I know by the balanced reaction that 2 moles react with 1 mole of calcium carbonate. It means 18.75 into 10 power minus 3 moles will react with half of it. Unitary method I am applying. If it is not clear, let me know. Okay. So once you calculate, you will get 9 point something, okay, 375 into 10 power minus 3 moles. Or you can say, you can convert it into millimoles also, or you can convert it into grams also. Okay. So I'm writing it again, sorry, 9.375 into 10 power minus 3 moles. If you want to convert it into grams, the molar mass of calcium carbonate, that is something you should remember, 100. Molar mass of H2SO4, 98. Molar mass of glucose, okay, 180. Molar mass of sucrose, 342. These are very frequently used, you should remember. Calcium carbonate, 100. It means when you multiply it by 100, 9.375 into 10 power minus 3 into 100, those many grams. When you convert mole to grams, you multiply by molar mass. Molar mass is 100. Any confusion, don't hesitate to ask. Okay? So if you multiply, it will be whatever this 10 power minus 2. So you can represent in grams, or you can represent in milligrams also sometimes. If there is any confusion, don't hesitate to ask. Just go through the question again, and I am telling you, if there is any confusion, ask again.
Sir,
Yes.
so please explain the last step.
Last step means when I converted it to mole, or when I converted it to grams.
Sir, the mass of the CaCO.
Okay. Uh, you know that when you have 1 mole and you want to convert it to mass, you need molar mass. So do you remember this relationship with that diagram? That 1 mole, you will multiply mole by molar mass to get the mass. In case of CaCO3, this molar mass is 100. Calcium is 40, carbon is 12, oxygen is 16, multiplied by 3, 48, which will give you 100. So molecular mass is 100 U, or molar mass 100 gram per mole. It means if you have 1 mole, you will multiply it by 100 to get mass. So 1 mole will have 100 gram of calcium carbonate. But we don't have 1 mole. We had 9.375 into 10 to the power minus 3 moles. So we will get mass equal to number of moles multiplied by molar mass. That is 9.375 into 10 to the power minus 1. That is, you can say 0.9375, or you can say approximately 0.94. Is that clear?
Yes.
Yes.
So that's what the answer is. It is 0.9375 gram. This is question number, I think 35 probably, or 36 of NCERT. So make sure that you redo this question. Very frequently, this question or very similar question is asked. Next question is again of NCRT because this is asked again and again. That's why I have included it here also. This one is welding fuel gas contains carbon and hydrogen only. Burning a small sample of it in oxygen gives this much carbon dioxide and this much water. This statement is important. This has gas has only carbon and hydrogen, means it is hydrocarbon. So if it is hydrocarbon, this will be something like CXHY. And
Yes, sir.
when it is burnt, it will react with oxygen, some amount of oxygen, and it gives carbon dioxide and water. The important point in this question is whatever carbon you have in the product, carbon dioxide, and whatever hydrogen you have in the product, in water, that will come from this organic compound, welding fuel gas. Oxygen obviously will come from air because you are burning it in air. But this carbon will be equal to this carbon. This amount of hydrogen will be equal to hydrogen present in water. Whether it is clear or not, these amounts will be same. Whatever carbon is present in the fuel gas, same amount will be present in carbon dioxide produced because you can't get carbon from anywhere else. The atmosphere does not contain carbon. Similarly, the atmosphere does not have hydrogen, which could react in, with oxygen. Now further, it says it gives 3.38 gram of carbon dioxide. You get 3.38 grams of carbon dioxide and 0.690 grams of water. It means if you can get in this carbon dioxide how much carbon is there, and you can get in this amount of water 0.690 how much hydrogen is there, same amount were present in the welding gas. So you can get exact amount of carbon and hydrogen from these two values. And how you can get? Because you know the relationship. The relationship is CO2 total is 12 plus oxygen 16 into 232. That is 12 plus 32 is 44 gram in 1 mole. If I am talking about 1 mole. But how many carbon, how much carbon is there? 12 grams only. So it means 44 grams of carbon dioxide contains 12 grams of carbon. Any confusion here? Or just let me know if there is any confusion. Okay. It means whatever amount is given, what was the amount? I think 3 point something, hence 3 point something grams of carbon dioxide will contain how much?
3.38 gram.
3.38. Okay, good. Thanks. 12.44 in 12 by 44 into 3.38 grams of carbon. So it means the carbon dioxide which you got here, it is 3.38 grams, but this 3.38 grams has this much carbon. It means the same amount of carbon was present in the hydrocarbon. So you got the amount of carbon present in the hydrocarbon. Remember, this is grams. You will have to convert it into moles. So whatever amount you got, that is in grams. To get the number of moles, why do you get number of moles? Because the formula of a compound is in molar ratio. If suppose I have written that it is C2H6, say ethane, so that exactly means that I have 2 moles of carbon atoms and 6 moles of hydrogen atoms. So the formula is in molar ratio. So it means I need moles of carbon and moles of hydrogen. So going back, because I need empirical formula, it means I need the molar ratio of the atoms. Or the moment you get the masses, you can apply that table which you already know. Okay. Carbon, hydrogen, whatever amount you have in mass, then convert that mass to moles, then ratio, then simple ratio. Can you recall that or not? No, I'm not getting it. If you are not able to recall, tell me. Am I audible to everyone?
Yes, sir. Can you repeat?
Yes, sir.
Yes.
Okay,
Yes,
good,
sir.
Yes, sir.
good. Now coming back to the question. When I say that 3.38 grams, I will calculate the mass of carbon. So 44 grams of CO2 contain 12 grams of carbon. Hence, 3.38 grams of CO2, which we have obtained, will have 12 by 44 into 3.38 grams of carbon. Okay. So it will be 12 threes are 36 around. So you will get around 0.92 grams of carbon. Similarly, you will calculate in water. You know that 18 gram of water contain 2 grams of hydrogen, H2O. So 2 plus 16, total 18. But out of these 18, how much is the water? Sorry, how much is the oxygen? 16. How much is the hydrogen? 2. So 18 gram has 2 grams of hydrogen. Hence, whatever is the given amount, I think 0.69 probably was given. 2 by 18 into 0.69 gram. Calculated. 1 by 9, it will have approximately 0.07 approximately grams of hydrogen. So you got the mass of carbon and mass of hydrogen produced, and that has come from the welding gas. It means welding gas has carbon and hydrogen. Carbon has 0.92 grams, and hydrogen it has 0.07. I think it was 0.69,
0.77.
0.77. I will have to just calculate because
So it was 0.077.
0.77. Yeah, because otherwise you will not get the answer correct. 0.077. Now, because this is the mass, then you will calculate the moles. From moles, you will get the ratio, molar ratio, and then simple ratio. So mole here will be 0.92 divided by 12 pi, because the atomic mass of carbon is 12. And 0.077 divided by 1 by, because atomic mass of hydrogen is 1. So you will get 0.077. Here also you will get 0.077. Okay. It means the simplest ratio is 1:1. The simplest ratio you got directly, you don't need to have another column. It means the empirical formula is CH, C1H1, CH. So empirical formula is CH. Let me know up to here is clear or not. If it is not clear, let me know.
So it's clear, sir.
Clear?
Clear.
Now
Yes,
come to
sir.
the second point. You need to calculate molar mass. To get the molar mass, you need to use the information given here. Volume of 10 liter measured at STP of this welding gas found to weigh 11.6 grams. Now understand the relationship. The relationship, if you remember the diagram, this is the relationship I am talking about, mass and volume. It says that 10 gram of it is equal to, sorry, 10 liters of it is equal to 11.6 gram. 11.6 gram is equal to 10 liters. This is given in the question. But how much is the volume at STP of 1 mole?
22.4.
22.4. And 22.4 liter weighs equal to how much?
11.6 divided by 10 into 22 by 4.
Yeah, that's fine. But if I'm talking about 22.4 molar volume,
So it will be
weight will be equal to its weight will be equal to its molar mass. Is that clear or not?
yes.
Because that is equal to 1 mole.
Yes.
So 22.4 liter will be equal to 1 mole, and it will weigh equal to its molar mass. So with this information given that 10 liter weighs 11.6 grams, you can get how much will be the weight of 22.4 liter by applying unitary method. And that will actually be molar mass because that is 1 mole. Clear? Any confusion, let me know.
Yes, sir.
Okay, so
Yes,
you
sir.
will say as 10 liter weighs 11.6 grams, hence 22.4 liter will weigh 11.6 divided by 10 into 22.4. When you calculate, you will get approximately 26 grams. It will be 25.97 something, but you will consider it as 26. So if it is 26 and empirical formula was CH and empirical formula mass was 12 plus 1, that is 13. C plus H, 12 plus 1, 13. And molecular formula mass is 26 because it is molar mass. This is molecular formula mass. So the factor n by which you need to multiply the empirical formula to get the molecular formula. So this is the second part, okay? 26 grams per mole is the molar mass. So you got the second part. Now I am talking about the third part. That what is the molecular formula? Molecular formula you will get if you multiply the empirical formula by a factor n, where n is given by molecular formula mass divided by empirical formula mass. Molecular formula mass is 26, empirical formula is 13. It means you need to multiply empirical formula by 2. So that will be C2H, ethine or acetylene. Is that part clear or not?
Yes, sir.
Okay, you will
Yes.
most
Yes, sir.
probably get this question or very similar question in your exam, half yearly exam I am talking about. Okay, these two questions are very important from half yearly perspective.